tell me to speak up. I also sometimes start talking too fast, so then you might want to just ask me to slow down. Thank you very much, Jim, for inviting me to come out and talk, and for all of you. I'm really excited. This is the first time I've been out to the California meeting, so this is really a wonderful opportunity for me personally just to learn about all the great work you've been doing. I certainly read about it a lot and have heard about it at other conferences, but this is really exciting. You'll notice that your program also notes that Chris Faulkner, also from EPA headquarters in Washington, D.C., was going to be here. He sends his apologies for not being able to attend. Like Chuck Hawkins, he is not feeling all that great, but he was one of the folks who, as Jim mentioned, happened to have been here working in Region 9 when all of this started, and he actually is really proud of the small role that he played in that. And so I know that he sends his congratulations on 25 years, and I take away from that what a wonderful job he did as a headquarters employee, which is to go out, do something small and good, and then never come back and mess it up. All right, so I'm going to get into my talk just a little bit. I want to talk about the National Aquatic Resource Surveys, which I think are really a here we go. Great program. We, like the USGS, are really looking at water quality across the country, and we are working with a wide variety of water body types. This is a quote that Steve Paulson, who many of you may know from our Office of Research and Development, uses quite a lot, that helped kickstart many of these sort of national level consistent monitoring programs. One of the EPA administrators from back in the late 70s, early 80s, was asked about improvements in water quality, what was the Clean Water Act, accomplishing, and he said, I'm pretty sure it's improving, but I can't prove it. And I think that's been the case for a lot of us. I think that's been some of the things that have led you all to doing the great work you're doing here in California with this very diverse set of data that you collect and the continuing long-term data that you're investing in. So just a little bit of background. In the 1990s and 2000s, we were at EPA continuing to get quite a lot of constructive criticism about the quality of water quality data, both in terms of information that states and tribes could use to drive decision making, as well as things that EPA could do at the national level. And we started talking about the need to use a wide variety of tools to answer all those different questions at a wide variety of scales. So that included predictive tools, models like Bob was just talking about, statistical survey designs, which is where the NARS program comes in, as well as targeted monitoring designs and other innovative approaches so that we can really fill those gaps that people were identifying. We were particularly lucky that we were able to put forward a request up through Congress for funding to support monitoring. We affectionately call it the Monitoring Initiative. It is a portion of state and tribal Clean Water Act Section 106 grants, and I'll talk about that a little bit later. But it supports two different things to do with state monitoring programs. One is to implement their state monitoring strategies, and the other part is implementation of statistically valid assessments of the nation's waters, which is the NARS side of things. As Terry talked about, we were really fortunate in the Office of Water that as this identification of these needs was growing, that our Office of Research Development had already been out working with our regional offices, with states, to develop the environmental monitoring and assessment program, including all of the tools and techniques that sort of undergird that program. So we were able to take that and actually implement it at a nationwide level. The Western EMAP served as the first sort of really big continental scale example of how this could be implemented. And the first sort of start of NARS was adding the eastern half of the stream survey to Western EMAP, and the rest of the program grew from there. All right, so many of you probably have seen this before, but our objectives are sort of threefold. First, we really are focused on assessing the biological conditions and changes over time in the nation's waters. Over time, we have started adding some recreational or human health indicators to that initial set of indicators that was looked at. We also want to be able to rank stressors related to biological conditions. So if I go to talk to my management, what should I be telling them are some of the important things we need to address if we want to see improvements in our streams, our lakes, our coastal waters. And then finally, we do want this to be a collaborative program where we're helping to build and enhance state and tribal monitoring programs. And one of the things that I think we've been trying to do a better job of is really learning from you all. So what can we take from the work that you guys are doing and bring back to the National Aquatic Resource Survey so that they continue to improve? All right, so alliteration is always fantastic, so I have this slide. So some of the things that we think that are pretty important about the National Aquatic Resource Surveys and that we're trying to talk to some of our newer management about are the fact that this is a very cooperative program. This isn't something that's done by EPA alone. This is something that states, tribes, other federal agencies, we work a lot with USGS on a variety of projects, do in order to make this program happen. It's continental in scale. It is primarily focused on the lower 48, but there are special pilot projects that go on in Alaska and Hawaii, as well as some work in the territories. It's also covering a wide variety of water body types. So we do focus on rivers and streams, lakes, wetlands, and coastal waters. We also think that it helps with those information gaps, not all of them, obviously, but in a cost-effective manner to sort of look at that national scale information. We use consistent methods and indicators, much like you are doing here in California, and continuing to work on that, so that the data that we collect in New Hampshire, we can look at and talk about it in relation to the information that's collected here in California. And then finally, it's complementary. Again, we want to stress this, and we know this doesn't always come off, but we know that this is only answering a certain portion of the questions that need to be answered around the country. So we do think that it's complementary to the work that folks are doing with other types of monitoring, so that we can continue to look at whether or not we are meeting our Clean Water Act goals, protecting and restoring water quality. A couple of other key points just to note, for those who are not maybe that familiar with the surveys. This is a statistically based survey, so we randomly select sites across the country. We are sampling about 1,000 sites each summer. This past year, we were out in the field for rivers and streams, so about 1,000 sites sampled for rivers and streams across the lower 48. Rivers and streams is our sort of odd duck in that it gets 2 years, so there's another 1,000 sites that will be sampled next year. And then we'll switch over to coastal waters and then back to wetlands and lakes. All right, so just a few examples of the types of indicators that we collect. These are very similar to the types of things that you all have been doing here for years, including benthic vertebrates, fish community. In wetlands, we're looking at plants. As I mentioned, we've added in some human health or recreational indicators. Key stressors, these are the kinds of things that we can't monitor everything all the time, and so we focus in on some of the nutrients and excess sediments and degraded habitats as key things we want to make sure we're tracking over time. And then always research indicators that get included in the surveys. eDNA, that's something, the metagenomics that you guys are working on. We've got some projects as well. Really interested to see how those can come together and continue to teach us about the things we should be doing in the future. Algal toxins certainly is something that in the news all the time now. And so we've included more and more algal toxins into some of the work that we're doing just to see what it looks like across the country. So just a few examples of those kinds of indicators. These, I should point out, these are not the same within each water body type. They do vary depending on which survey we are implementing at the time. All right, so as I mentioned before, partnerships are critical for implementation of this program. We have about 10 people in Washington, D.C. that work on this team. It is really something that is implemented not by those folks, but by our regional offices, Office of Research and Development, all of the states and tribal folks who are out in the field, in the lab, doing this work. We do include, for every single one of the surveys, has a steering committee of state and tribal folks as well as EPA staff who participate on development of sort of the plans for each of the field years, talk through the various indicators that we're implementing, and continue to provide us with great insight on things that we can do to make improvements. There's also a sort of more management level group called the Monitoring and Assessment Partnership that is providing us with additional policy feedback and has been working on a variety of things this past year to help us make improvements to the program. The final one here is just sort of takes a look at what the funding is for this program. Through the state and tribal grants, we have about $8.5 million that comes in for that NARS side of the monitoring initiative. EPA also puts in around $3 million to support the logistics, the training, the data management, all of those aspects of the program. And then research is usually done as a supplement. So maybe our Office of Research and Development has some funding that they can put in to help with analysis of the eDNA, or another group comes in and is really interested in a particular indicator. And so additional funds may come to bear for those. All right. I am not a scientist, so I will have very few graphics, and they will be simple. But this one I just thought was an interesting look at the number of states who have participated in the various NARS surveys over time. Coastal looks off, but that's because it has far fewer states who are eligible to participate in the coastal survey. We do include the Great Lakes, so there's a few extra that you might think about if it's only marine waters. But relatively, we've been stable in terms of the number of states who have participated in field work. And we really think that's important. It helps us really understand how those methods are working, or similar or not similar to what the states are doing. And we think it makes folks in the states also sort of have a better understanding of what the data are once those data sets come back. And I should point out also that as Jim was mentioning, California has participated in every single one of the surveys directly for field work, and almost every single one of them. They've also done some of the lab work, which is not typical for a lot of the states. So that's really been wonderful. All right, so the next few slides I'm going to present are just some of the results that have come out of the National Aquatic Resource Surveys. This is sort of our general condition slide where we're looking at biological information. And I presented this nationally for each of the most recent water body types. And you can see they do vary, coastal looking sort of the best, as it were, to rivers and streams, which has the fewest, the smallest percentage of waters in good condition. And I've broken a few of those down further. This is not California's data from the PSA. This is actually information from the NARS survey, so please bear that in mind as you're thinking through information you're used to seeing. But I thought it was interesting to take a look at what the NARS data was saying about California in relationship to the larger western ecoregion and then nationally. I did take a look at I think it was the 2015 PSA report, and these California numbers aren't too far off from that, I don't think, but certainly a little bit, and there's a margin of error around those because we only had 67 river and stream sites in California. So I did something similar for the coastal sites. Again, here it would appear that California's waters are looking a little bit better than the West as a whole, and certainly then nationally. Again, there's error bars around those, but another just interesting way to sort of be able to look at the data. One of the states up in the Northeast, Vermont, did something similar to this with lakes physical habitat data, and was really surprised to see that they looked worse, not only than the physical habitat data did nationally around lakes, but also within their ecoregion. And I think they compared themselves to New Hampshire, and that, along with other Vermont data, drove them to being able to talk with their legislature about better protecting habitat around lakes And they actually passed legislation to do that, and then went out with a big campaign out to lake associations and others who live along lakes to talk to them about what they needed to do to protect and restore water quality. So there can be power in being able to sort of look at this information at different station scales. All right, I also mentioned that we are trying to look at the different types of stressors that are impacting our waters. No big surprise here. We, like you and others, are finding that nutrients in degraded habitats are big problems across the country. So I won't go into those into greater detail. So again, I think these are the kinds of things that we are all seeing in our data sets. To focus in a little bit more on phosphorus, one of the things that some of our researchers did was to delve a little deeper into the data that we had available from rivers and streams of lakes, looking at phosphorus concentrations. This is in a paper by Stoddard et al. They were looking at the proportion of stream length or the number of lakes in the country that had total phosphorus that was 10 micrograms per liter or less. So these are very oligotrophic systems. And then tracking those proportions over time using the NARS data sets. So you can see in 2004 for streams, we showed about 25% of the nation's rivers or stream miles had 10 micrograms per liter of total phosphorus or less. That dropped off by the 2008-2009 survey down to about 10%. And in the 13-14 data, continued that decline. As Bob said, we want to continue to watch this over time to see whether this is actually a trend or if this is something else going on, and we will start to see sort of bounces back up. But interestingly, we saw the same type of decline in our lakes data set. This is continental scale wide. This wasn't happening in only one part of the country. And so the paper does take a look at some of the types of things that they thought might be driving that. They were able to rule out, at least in their opinion, a number of those, and sort of left the paper with this could be something that's related to air deposition, but still more research to be done. And we certainly want to continue to look at additional NARS data to see if this continues. This is another example of the same type of plots, and I should mention that Michelle Mayer, who is at ORISE working with us, is the one who created these for me, so I created that paper for her. Again, looking at California, the West, and nationally, the percentage of lakes in good, fair, poor condition based on total phosphorus concentrations. Again, California looking better than things do nationally, and pretty close to things across the West. And I pull out one wetlands example. This is their hardening stressor where around the wetland plot, where they were seeing things like roads or other features that were compacting soil, basically. And in this case, while the West as an ecoregion did not look all that great, California was looking better in terms of the wetlands that were sampled here, and very similar to what was going on nationally. Greg Sarabetz, who leads up our wetland survey, did want me to make sure to mention that we know that there were some issues in the western ecoregion in terms of the number of sites that we had, and some of the types of wetlands that ended up getting sampled in 2011. Before the 2016 survey was initiated, we did do some refinements to the design, so we're hoping that we are going to have the ability to better tailor the thresholds that are used for looking at information in the West, and even differentiate between several of the ecoregions, which we were not able to do in the first wetland. All right, so one other thing that we try to do between the biological information and stressor data is to look at that interrelationship. These are not causal analyses, but they do look at how likely you are to see poor biological condition when you have, say, high levels of phosphorus or excess sedimentation in that particular well body type. So the example here that I'm showing is from NERSA, the graphic, and what we are looking at is
in 2013-2014, we had about 44% of miles of least disturbed condition or poor for macroinvertebrates. If we were able to address areas where we have high phosphorus, this particular analysis suggests that we will be able to reduce the amount of poor condition we have in biological condition in streams across the country by about 25%. So this is not, it assumes that each and every one of these indicators of the stressors is acting independently. So there's a number of assumptions built into this analysis. But it is a way for us to talk to our managers about some of the things that would be most important to do. One really great example, sort of following up on the acid mine drainage study we were just looking at. We know that where acid mine drainage occurs, it has a really, really large impact that needs to be addressed. However, nationally, the amount of stream miles impacted by acid mine drainage is relatively small. And so trying to do that kind of work, quote unquote, everywhere wouldn't make any sense. Whereas to some degree, really focusing on things like phosphorus pretty much across the country make a little bit more sense. So something that we're able to talk to our management about to try to give them some ideas about nationally, where is the best place for them to be putting their funds, their programmatic resources. All right, so just 3 examples of information from our recreational or human health indicators. As I mentioned, we've been adding in algal toxins across the water body types. We've actually looked at microcystin in each and every one of the surveys now. So we detected them in 40% of lakes and rivers and streams and about 12% of wetlands. Note also for wetlands, we don't get water everywhere, so we have a larger percentage of non-cess waters. But in all cases, at least for microcystins, there were very low levels above the World Health Organization's risk value numbers. We're not chasing algal blooms. We're not targeting specific times of the year where that might be the most concerning. So there are some caveats to this information. But again, tracking over time whether we're seeing some of the changes in that, I think will be interesting. For enterococcus, we also looked at that particular bacteria in lakes and rivers and streams, and we did see them above human health criteria in 4% of lakes and 30% of rivers and streams. So we're interested to see what the data look like coming out of future surveys. And then fish tissue we have been including in both the coastal survey as well as rivers and streams. And not surprisingly, we see mercury everywhere, at least detections of it. And again, we're in that 25 to 30% exceeds level. Our Office of Science and Technology also took a look at some PFAS, and we're continuing to do that. So we are seeing PFAS levels above criteria in about 24% of rivers, depending on which exact criteria you're using. Additional research coming. They're really excited about the opportunity to continue looking at that particular issue. Again, it's something that our management asks about a lot, and we've been seeing it. All right, so I also mentioned that we have been working with a wide variety of folks on improvements to the National Aquatic Resource Surveys. We're not 25 years old yet, but we have gone past the first 10 years of implementation as NARS. So some of the things that came out of a meeting that we held in December of last year were definitely, pretty much every other comment, I think, was that we are too slow at getting data back out to folks, both to our partners and to the public at large. And we know this is an issue, and we are working on improving that. We've gone through some lean exercises, if any of you are familiar with the Kaizen approach to looking at your processes and trying to figure out ways to improve what you're doing. We've also started a state EPA work group to take a look at some products that we've developed, both to
communicate where we are in the process, which is sort of step one, so that people are aware of what we're doing, as well as to work on speeding up delivery of those data sets. So one of the tools that we've drafted right now is simply nothing more than a dashboard that folks can take a look at to see how many samples have been processed by our labs, how much QC have we completed, and whether or not we've posted those preliminary draft data sets to partners on SharePoint or some other fabulous place better than SharePoint that we use. We've also started a communication and outreach group. I think I'm really excited for the data visualization agenda item that we have coming up. We are really trying to focus not only on our sort of traditional way of communicating information, but finding better ways to provide the data for communicating to technical audiences about the availability of information, communicating to management about the implications of data, and getting the public to understand what some of this information means. Not in the way that I think they should understand it necessarily, but in a way that they can actually relate to it. And then we have a methods and indicators work group. Folks who are very interested in several things related to methods and indicators. Sometimes it's new indicators we want to add. Sometimes it's discussions of whether there are indicators we could remove. And there's certainly the component that is, well, we don't sample quite like that. What could we do to utilize state information in the national assessments, or other ways that we could start to look at tweaks between the methods that we have and methods that other folks have. That's something that we want to look at. It is a little difficult for us because we often have to try to take our method and compare it to 48 methods, and certainly is a challenge. And then finally, training. We know that the NARS trainings take up a lot of time and resources. So for those of you who have attended, you already know that. For those who haven't, every field crew who participates in the survey has to come to an EPA-sponsored training. Rivers and streams training has traditionally been 4 days, as has the wetlands training. Lakes are 2.5 to 3 days, and similar for coastal lakes. So this is not a small commitment, particularly if you have a crew of 3 or 4 people that you would like to have attend that training. So we are starting to take a look at different types of tools that we can use to deliver that training, to be responsive to the fact that we can use videos and a variety of other tools. So we're going to be piloting some of that over the course of the next year. And then finally, I just wanted to mention that we are entertaining a design implementation proposal that ORD put on the table that they think could improve our ability to detect trends. Right now, as I mentioned, we sample each water body type in a rotating cycle, so rivers and streams. Then we stop doing rivers and streams sampling. We focus on coastal waters for a year, then lakes, then wetlands, etc. This particular proposal is to sample a proportion of each of those water body resources every single year, which is obviously a big change for our program. A number of things about it are really exciting. Some of the things that it could deliver in terms of being able to report out on all of those water resource types every year is really exciting. For some states, that really sort of evens out the effort that they have to put in. Coastal, for example, Florida gets something like 110 sites every 5 years. They might like to only have to do 25 or 30 in a year. For other states, it's actually the reverse. It's less advantageous for them. So lots of things for us to think through with that particular proposal. All right, so that's the end. We do have data from our public reports, all the data from those NAR surveys that have been published online. So you can go up and download it. We know it's not in the best format possible. If you do have questions about using it, please feel free to give me a call. If I can't help you, I'll get you in touch with somebody who can. We have dashboards. This is the coastal dashboard example available for both lakes and coastal waters on our website as well. That allows you to explore some of the results, not only for the national assessments, but looking at subpopulations like EPA region and the eco region. And we are planning to put those out to the other resources.
Thank you.